Hey guys, today we're going to look at, this will be video number 4 in our series on how to use our meter, and today we're going to have a look at testing for isolation and specifically the prove, test, prove method. So when I say testing for isolation, what do we mean? Well, as electricians, we're going to be going and working on live circuits all the time, and for our own health and for our safety, we need to be able to isolate that. I'm not going to go and work on something while it's still live. If I want to start pulling it to pieces, I'm going to need to turn that off first. This could be a socket outlet, it could be a lighting circuit, a light switch, a physical light fitting. It could be, if I was working in a factory or something like that, it could be a piece of machinery like a permanently connected lathe or welder, or just about anything that you could imagine that I would want to go and work on. Before I work on that thing, I'm going to want to turn it off. And so it's really important that an electrician understands how to do that safely and effectively. And it's more than just switching something off at the wall. There's a few other things that we have to think about. The first one that we're going to talk about is, how do I know when that thing is turned off? Particularly if a piece of equipment that you're coming to work on might be broken, relying on the fact that the equipment has no lights on it, the power light's gone out or something like that, is not a very effective form of isolation. We can't be certain that there is not power still on that piece of equipment. We would also find we could switch it off at the wall or switch it off at the machine itself, or whatever you like, but we would also find that that might be an issue too. A good example here would be if I was replacing a light fitting. I could simply switch it off at the wall, and that should effectively isolate the power going to that light fitting. The issue that we have there is that anybody could come and switch that back on. I don't know that it's going to remain safe and secure for me throughout the duration of the work that I'm doing. So not only do I have to be able to verify that something's turned off, physically isolate it at some location, but I have to have a method of making sure that that remains off. So most likely we're going to go to our switchboard to do our isolation. I'll go to my switchboard, find the appropriate circuit, switch it off, verify that that has been switched off at what I'm working on, and we go from there. So our verification, let's talk about our verification first. We're going to do what we call prove, test, prove method. Prove, test, prove means I prove my meter on a known supply. I then test the thing that I want to test, and I prove again on a known supply. Let's have a look at that. So I have with me here today just a power board here. This is handy because it's got a little light on it, so for the purposes of our demonstration, that will enable us to visually see when I've switched that on and off. Obviously, that is not something we would rely on. That's the exact type of thing that I'm talking about that we would not rely on. I also have here just a standard extension lead, and that extension lead is connected to a different supply. So when we talk about a known supply, it has to be something that's on a different supply to the one that we're going to switch off, because we want it to remain live while we're doing the work. Okay, so the first thing I'm going to do is I'm going to test the thing that I'm working on. That's going to be this power board. I'm just going to go phase to neutral, and we can see there that I have 230 volts. You'd have to trust me. I think that's a mirror image on the screen there. It's 230 volts as I can see it. So I know that that's still switched on. But I figured out that this little switch here should turn it off. And in fact, when I do that, the light goes out. That gives me an indication that it has in fact turned it off. But to prove that, to ensure that I'm certain that I have switched that off, we're going to prove, test, prove, right? So the first part will be prove. I'm going to plug my meter into a known supply. That is this socket outlet, which is on a different supply. I know that this is still turned on. I haven't touched it. And you can hear the beep on my meter there. That's telling me this supply is in fact turned on. So I have proved that my meter is working. I go back to the thing I'm testing and test again. I should be getting 0 on my meter, and in fact I am. 0 there. I'm going to go phase to neutral, phase to earth, that's 0, and neutral to earth, that is also 0. So I have tested all 3 pins on the socket and proved that that is dead. However, something could have gone terribly wrong. I could have, in between the time that I proved my meter on a known supply and then tested the thing that I've turned off, something could have gone wrong in my meter. It could have blown a fuse or something like that. I could have been plugging this in and get a false reading, and my meter says there's 0 volts there, but there is in fact volts there. So after I have tested, I'm going to prove my meter again. I go back to my known supply. I put it in phase and neutral, and I've got the beep and the little light, and it says 230 volts on my meter. That proves to me again that my meter is still working. So I proved my meter on a known supply, tested the thing that I've turned off, and proved my meter again. Now I know my meter is still good, so the reading I got when I turned that thing off must have been good. Now obviously, as I said, this guy here has a little light on there that helpfully tells me when I've turned it on and off. In fact, if I wanted to work on this, I would physically unplug it, I'll take it away, and then it can't be live if I've got the whole thing in my hands. But that's not always going to be the case, clearly. So how do we identify what we're turning off? That's really important. The first thing that we must do when we want to switch something off is identify what it is I'm switching. The isolator can be anything we like. If it's a permanently connected appliance, if it was a welder or something in a factory, it might have an isolator on the wall. In fact, it should have an isolator on the wall. That is a great place to perform our isolation. Anywhere that is locking, I can switch that off. If it has a locking mechanism on there, I can put a padlock on there, and that proves, that gives me that isolation and makes sure I'm proving to myself that that will not be turned on again. It cannot be turned on again by anyone because I have locked it myself. Most cases, however, we're going to have to go back to the switchboard, particularly in domestic situations. And you'll find in these sort of domestic situations, switchboards typically that look like this. And you'll notice there that that's fairly complicated. There's a lot of wires there, right? This is a fairly typical board. I can see I've got a main switch on the left, that's the red one, a few breakers which are probably hot water in the oven, something like that. An RCD with a few more breakers that are probably powered from that RCD, RCD2, a few more breakers, RCD3, RCD4, RCD5 even. So a number of RCDs. I've got at least 15 sub-circuits there. Any of these could isolate the circuit that I'm looking for. So on a modern switchboard, often it will be labeled, which is really handy. It might say power points in the garage, bedroom lighting, something like that. That's a great place to start. If I switch that off and it switches off the thing that I'm looking at, that's really good. Then I go and do my prove, test, prove, right? Don't always rely on the labels. Things could have changed. Somebody could have moved something around. The labels could have been done wrong, incorrectly at the start. So we use the labels as a guide, as an indicator. We still are going to do our own prove, test, prove after we've isolated it. The worst case scenario, if you've got no way of telling, particularly with older switchboards, which isolating device switches off the circuit I want to work on, I'll have to use trial and error. Now that might take the form, it might sound crazy, but it's true. If there's no other way to do it, then trial and error is what it is. If I switch somebody's fridge off for 5 minutes while I'm mucking around trying to find the thing, it's not the end of the world. It's certainly far less of a drama than me electrocuting myself because I was too scared to start switching things off to try and find the thing that I want. A little tip for you, what I find quite helpful is plug a radio or anything that makes noise into the outlet or onto the circuit that you're going to be working on. That way when you go to the switchboard, if you can hear that radio, as you flick off the circuit breakers, the one that makes the radio stop, that must be the one that I'm looking for. Then I can turn everything back on. I go back to where I'm working, unplug the radio, do my prove, test, prove. Remember, proving on a known supply, so that's some other socket or some other power supply that I have not switched off, to make sure that my meter is working before and after testing my isolation, and then I'm ready to go. I think that's it. Next video will be insulation resistance testing. Ooh, that'll be fun. Stay tuned.